We've been able to print messages to the screen so far using these double quotes. So something like this would print hello world, right? These double quotes represent a message, or what we would call a string. In this video, let's take a closer look at strings and how we can use them as data types aside from just straight into cout where we would print it. Now, like an integer or a float or double or a character or boolean or any of those, you can declare a string using its name and then the variable name that you want. So here, let's just say I'll call it str. Like any other variable, I can set this to be things. So here, let's say I set it to be hello world. A string, like we've done so far, has to have double quotes around it. That's how we designate that it is actually a string. Here, let's just say I throw this out, and I can now try to print the string rather than just directly have this text in there. If I was to run this, we should see that we'll get hello world. There we go, and so it runs. We'll give it a second. And we see hello world, right? I can modify this string if I wanted something else to be printed, so let's just say print this string. And we should see that that now gets printed. And there we go. So like any other variable, we can use a string and set it later over the course of the runtime. Now, why would you use this over just throwing it in there? Well, we might be able to modify this string before we actually print it. So let's just say I wanted to add two strings together. I can totally do that as well. So far we've gone over adding two integers or adding two floats, basically two numeric types, but we haven't gone over adding two strings. That is allowed in C++. Here I'll just do a second string, let's just say hello world. And what I can do if I want to put these two strings together is simply use a plus. C++ is a little strict about this. You can only add two strings together. You can't add a string to anything else unless we first convert it to a string. Here you'll see that we have print this string and then hello world, so they got added together. When we add two strings together like this, this is called a concatenation. What it means is that we basically take this first string and the second string and we kind of paste them together. We put them side by side, right? So that would be called concatenation. So we concatenate these two strings. One other thing I want to note before we get too far is depending on your compiler version, you might have to include the string library in order to use it like this. Here in Visual Studio it seems to be fine without me including it, but just in case, you may have to include either string or string.h. So here I could include string, or string.h also works. Just in case you're getting compiler errors where it says that string isn't recognized, that might be the issue. But I think Visual Studio automatically includes string for us. Now a string is a collection of characters, whereas a character was something like this. Character, let's just say C was equal to, I don't know, we'll say the letter D here. A character had single quotes and it only represented one single character. A string is a collection of characters, so it's one character after another. So here, if I looked at the hello world string that I have, the first character of this one is a space, the second one is H, the third one is an E, and the fourth one is an L, and so on and so forth. So a string is really just a sequence of characters. And because of that, we can access that sequence and get individual characters if we want to be able to access them. So for instance, let's just say I want to get the H in string 2. What I could do is I could simply say cout str, and then position 1 would be the H. So in computer science, we start counting at 0. We'll go more into detail into this when we get into arrays. But this space would be in position 0, this H is in position 1, E is in 2, and then so on and so forth. So we start counting at 0 and then count our way up. Kind of like we did with the argument vector, the way we access things that are in sequence like this, which are called arrays, we'll learn more about them later, is we simply use these square brackets. So here, if I do square bracket 1, it will go to the first position, which is this one, and it will grab that character. Here, let's just make sure that that works. We'll print it really quick. And you'll see that it runs, and we get a R. And the reason it did that is because I printed string 1 instead of hello world. But if we double check that string 1 that we saw here, this str, then we see that the 0th character is P and character number 1 is R, so that's why it's printing it. We will do some more examples with this in the future. I just want to give it out as a baseline here. Now, the last thing we should probably go over is the encoding scheme for a string. And what that means is, how do we go from something in binary to each of the characters that make up the string? Now, a string is made out of entirely characters, so each position is a character. And if we were to look at each of those positions, we could be able to figure out exactly what character those are from a table. In America, we use this thing called an ASCII table. What you use to encode can depend on where you're sending messages to or from and the language that's used in the region. So here in America, we use an ASCII table, which contains all of the Roman letters, all of the Arabic numbers, and some other things that we'll just take a quick look at. And if you were to go to, Japan, you might see that they have Japanese characters. If you were to use a computer in, let's just say, Spain, you might see that they have accents over some of the characters, and you might need a more expanded table than this one. This one is only showing about half the numbers that it's capable of, so there would be 256 possible combinations for these. This ASCII table only goes up to 127, which is really all we'll need for now, I believe. Anyways, each character represents a specific number in the computer. Since they have a binary representation, that's what a computer has to store things as, right? Then they have some sort of numeric equivalent, and then we use what's called a numeration, basically where you just use a number to represent something else, or an encoding scheme, I guess you could say. So for instance, in this encoding scheme, I typed in the letter capital D earlier. That would be the number 68 in decimal, or the number 44 in hex. C++ will allow you to use decimal by default, so if I wanted to, then I could always treat this here as the number 48, I believe it was, that was in our table here. Right? I'm sorry, 68. 68 is D. So in my code, when I set character C equal to D, all I'm doing is I'm setting it equal to the number 68 that represents. Because of that, we can do some things where we actually use the character for math, or we check its value. We will go into an example of this later when we do maybe the next section, but for now, just know that these are represented with numbers. Let's do one quick example just to see the encoding scheme here. So let's just say I wanted to write out the string hello, and I wanted to see what the encoding of that would be. If I had the string hello like this, then as far as the computer stores this, it's going to be as a series of numbers. So the first number is going to be the number that corresponds to a capital H. The capital H here is the number 72 in decimal. So we'll just deal with decimal for now. We won't worry too much about hex. Hex is basically just a way, if you're not familiar with it, it's a way to translate directly from binary to something shorter. So if I wanted hello as a string, in terms of characters, it would just be 72 as the first one, and then the next position, so I'm just going to draw this as like a quick little table here. Make that a little bit longer. The next position would be a lowercase e. So notice that there is a distinct difference between the capitals and the lowercase. Pretty much anything that you can type on a keyboard you should be able to find in this table. Here we see that E is the number 101, lowercase. We see that the letter L here is 108, so the next two positions are both 108. And then the last one is an O, a lowercase o, which is 111. This string in the computer will look exactly like that as far as if you were to look at it in decimal. Because of that, we can actually do some checks with this using integer representation. Lastly, let's just take a quick look at some of the other parts of the ASCII table. Let me erase this just so we can see a little bit better. You'll see that the capital letters are all next to each other and the lowercase letters are all next to each other. Because of that, we can do some checks to make sure that, for instance, that a letter is between 65 and 90 if we wanted to make sure it's a capital, or that it's between 97 and 122 if we wanted to make sure that it's a lowercase. Again, we'll go into that a little bit more in detail when we get into how we can check things like that. You'll also find all of your punctuation marks and numbers, so the numbers are right here. You'll see that we have punctuation marks like commas and pluses and times and parentheses and stuff like that. And then the first set of ASCII characters here are generally going to be things that are used for the computer to recognize certain flags. So they may be null, or the start of a text, or the end of a text. Null is probably the most important one. Whenever you write a string, the way a computer is able to tell that you are at the end of the string is it actually just throws a null at the end so that it's able to tell where it ends. And the reason it does that is because a string is of variable length. And what that means is that whereas something like an integer is always 32 bits, that's 4 bytes, and a double, let's just say, is always 8 bytes or 64 bits, they never change. They're always going to be that exact same length no matter what. And a character is the same way. A character is always 1 byte, which is 8 bits. But when we have a string, it's some collection of characters, and we don't necessarily know how many characters there are going to be. For instance, the word hello here has 5 characters in it, but if I wrote the entire string hello world, then that's more characters than that, probably about 12, right? I could be counting wrong, but that's just a ballpark guess. And because of that, it's not always going to be the same length, and so one way we can efficiently tell where the end is without having to keep track of the length is to simply throw a 0 at the end, because that way we know exactly where the string ends. Another thing to note, just because it does cause some confusion, is that these are characters, so they're representations as far as writing things down goes. So if I had 0 as a character, consider that that is not the same thing as 0 the number. So consider if I had the code character C, let's just say, equals 0 the character, and I had int x equals 4, then if I was to write the line of code C plus x, that is not going to work. And the reason that's not going to work is because this is a character and this is an integer. The example I use for explaining this is if you were in English to sit down and write something like this in maybe a math class, 0 plus 4, you would be kind of confused why the person is doing that. You're trying to maybe add something that's a word or a way of writing things down to an actual number that exists. So here just consider that characters are ways of writing down things or keeping track of numbers as a symbolic representation, whereas integers and doubles and floats and stuff like that are actual numeric representations that have a real value, whereas the other one is just a way to write it down. Anyways, that's kind of just a brief overview of strings and some more info on characters. In the next video, we'll take a look at some information regarding conditionals and how we can check things before we continue our code.